Joining us this Sunday for our weekly webinar is Ms. Dolapu Towalawi. She is taking us on the topic of advanced SQL query techniques for data analysis and reporting. So before I go further, I want to share that we are in a partnership with Enterprise DNA. Enterprise DNA is a platform that's used to empower Power BI users and teach people how to use Power BI and other data analysis techniques and software. So we are also in partnership with MHS Analytics Incorporated. So we teach people in Canada how to do financial modeling, BI solutions, and Excel reports automation. We also provide data analytics tech services to companies and high value professionals. So any person from Canada who want to avail of these services, please contact us at mhsanalytics.com and through our phone line at 437-677-5184. So about us, Yorbi's Edge, we are a registered Microsoft Excel consulting, financial modeling, business intelligence, data analysis, and enterprise solutions firm in Nigeria. And we specialize in helping companies and high-value professionals be at the top of their business data. So every weekend, we tend to host a Sunday webinar that puts spotlights on people, data analysis, working professionals that, that have that gives them a platform to showcase their skills, learn, and hopefully learn from each other. So we're hosting classes on in-depth Excel training, executive dashboards, and business data analysis. This is happening on Tuesday, March 14th. So we host plenty of classes for Power Query, Power Pivot, and VBA in Excel, and also for big data analysis. We also host classes for Python for data analysis for anyone who wants to learn Python. It's a flexible program and it's used all around the world. Also for SQL data analysis. So my guest today is Dolapo. Dolapo Towalawi is a fintech enthusiast with a proven capability to adapt to new challenges and environments quickly. She uses analytical skills to develop and expand processes that brings growth. Main qualities include problem solving, logical thinking, ability to work under pressure, team player, and excellent communication skills. She has a large variety of skill sets ranging from PostgreSQL, data processing, data mining, data exploration, Power Query, DAX, Advanced Excel, Microsoft Power BI, Tableau, Python, Microsoft PowerPoint, Microsoft Word, research, and ML. She's responsible for analyzing financial data, creating reports, and providing insights to support agency decisions. She has a deep understanding of financial concepts and regulations, and also uses her knowledge to help organizations to make better informed decisions. I'm going to pass this now to Ms. Dolapu, and we can start this webinar then. Dolapu, are you there?
Yeah, thank you, Chidi.
No problem.
Good evening, everyone. Let me share my screen. Okay, so today I'll be talking about advanced SQL query techniques for data analysis and reporting. So this is what I'll be talking about today. SQL, the uses, subquery, common table expression, and query optimization. So what is SQL? As we all know, SQL is a programming language and it is used for storing and processing information in a relational database. SQL is also used to manage and manipulate data, as well as also you can also use it to modify and create new database. SQL is used to perform various operations on data, including querying, updating, inserting,
Dolapo,
and
sorry. Oh, Dolapo, your screen, you're not
okay.
sharing your screen right now.
It thought I did. Okay, I'm coming. Let me stop sharing and share again. Can you see my screen now?
So if you can see our screen, can you
No,
just
it's
put
still
yes in
comes.
the chat box? But right now it's not up.
I don't know if you can view my screen now.
No, it's not visible now. It's not visible yet.
And it's sharing here.
So when you're sharing, right, you have two options: to share screen and to share window. Which one do you select?
I share the entire screen.
It's meant to show. Because everyone is saying they can see your screen. Can you just stop sharing and share again? How about that?
Yeah, stop sharing. I want to share again now.
Okay. It's fine. Just,
Can you see my screen now?
if you can see our screen, can you just put yes in the chat box? So I share gone. Abiodun. Nope. So
Exactly.
people are still saying no. I can't see it here. Oh, Chidi, can you see our screen?
No. I can't see it. Are you sharing screen or are you sharing a window? Like,
I'm
there's two
sharing.
options.
You're sharing
I'm
the
sharing
entire
the
screen.
entire screen.
Okay.
You're sharing the entire screen. Okay.
Um.
Can you
Okay.
see it
So
And
now?
Okay. It's not still up. So the laptop, right? So I was thinking of something. Can
Okay.
you like leave and join the section again? What about that? Is it possible?
Okay, let me do that now.
Okay. Thank you. I'm sorry about that, guys. We'll join very soon. Should then be monitoring when she comes back in.
yeah, no problem. Dolapo,
Yeah, I
you're
mean,
back.
Yeah, in right?
yeah.
Yes, it's coming up now. It's up now. Thank you.
Okay, thank you. Okay, like you said, SQL is a programming language used to manage and manipulate data in a relational database, and is also used for storing and processing information in a relational database. As you know, we can use SQL statements to store, updates, and search and retrieve information from the database. So what are the uses of SQL? We use SQL for data retrieval, for data manipulation, for reporting and analysis. We use it in the e-commerce sector and also for web applications. You can see for the data retrieval, SQL is widely used for retrieving data from database. It allows users to write queries that specify which data they want to retrieve and how they want it to be organized. And for data manipulation, data analysts use SQL for data manipulation and also for data exploration too. So let's move to subquery. As you all know, subquery is a query that is found in another query. And Sometimes subqueries replaces joins and union, and they are easier to understand. A subquery is used to return data that will be used in the main query as a condition to further restrict the data to be retrieved. More or less like we are using it to filter the main query. That's how subquery is. Subqueries can be used in various parts of SQL statements. We can use it in our select statements. We can use it for our updates. We can use it for insert. We can use it for delete statements. And we also have in our select statements, we can use subquery in different parts of our select statement. As we all know, the normal standard listing for SQL is select, from, and where, then having clauses. So we can embed our subquery in our select part, or we can embed it in the from, or we can embed it in the where. And also there are rules we must follow when writing our subqueries. Subqueries must be enclosed within parentheses. That is, when we're writing our query, we must enclose it with parentheses. That's to separate it from the main query itself. And subquery must also be placed on the right side of the comparison operator, like the comparison operator. And also, the between operator cannot be used with a subquery. However, it can be used within the subquery. What this means is that the between operator cannot be used with a subquery, but it can be used within our subquery. Subqueries with more than one row can only be used with multiple value operators, such as the in operator. An order by command cannot be used in a subquery, although the main query can use an order by. What this means is when we're writing our query, for the subquery part, we don't include order by. Instead, we can use group by to filter our query, and then we can now add our order by to our main query. So this is the syntax for subquery. Like, see, first you write your, for this syntax now, our subquery is embedded in our where clause. So you write your main query first, that's select, then the column name, select column name. That is the column name we want to create, like want to know more about. Then from the table name itself, and then we use for the where clause. For our where clause now, we have to reference the column name we are looking for, that's the where column name, and the expression operator we want to use, whether equals, whether in, or anyone. And then we now write our subquery statement, which is select column name from table name. Yeah, so our subquery is more or less like an independent query itself, because if your subquery cannot run on its own, then this thing might show error. Like when, if I want to write my subquery, I write the subquery first before I write my main query, just to see how my subquery is going to run first. When I take it to the database system, I will explain that. Okay, so let me just go to the database system so that we can see what I'm trying to explain. So I already created my table here, which is the sales data, and I already inputted it here myself. So for this data we'll be using, we have 10 columns in our data, which is we have transaction ID, customer ID, product name, category, quantity, price per unit, discount, date, and store location. So my first query, I'll be writing a subquery first. And what I want to do now is I want to calculate the average amount spent by each customer and their location. So as you can see this query now, my subquery is embedded in my from clause. You can see here, my subquery is embedded in my from clause. If I run this query, we'll get the average amount spent by each customer. But before, when the query wants to run, it will run the inner query first, which is the subquery. And this is the subquery here. That's select customer ID, sum, that's my calculation for my total sales. That is, I calculated the quantity, multiply the quantity by price per unit, and then multiply it by the discount to get my total sales. So this is in my subquery here. Select customer ID, then I perform this aggregation and then the store location. If I run this inner query itself, it's going to give me, let me run the inner query itself. So now this is the inner query. The inner query giving me the customer ID, then the total sales for each customer ID and their location. And now I want to calculate the average amount spent by each customer. So this is like a temporary table for me to run my main query. So now back to my main query, which is select customer ID, then the average total sales that I calculated in my subquery, and the alias given to it is average amount spent, and then the store location. One thing about this query is, because my subquery is in the from clause, when I am writing my select statement, I have to choose the column from the table, that's from my subquery table. That's where I have to choose all the columns I'll be using to run my main query. As you can see, yeah, my store location is in my subquery, and my average, this customer ID2 is also in my subquery. Then the total sales 2 is also in my subquery. You can see that I did not include order by in my subquery. Instead, my order by is in my main query because both perform almost the same thing in the subquery. So there is no point, since I'm still going to, because if I put my order by in my subquery and I don't put it in my main query, it's not going to give me the desired results that I want, because I want my result to be in the order of average amount spent in descending order. So now let me run the whole query. And now we can see that the customer ID with the highest average amount spent is 104, and then the store location is San Francisco. So that's for this subquery. Then let's look at another example here. Now this one is looking, now I'm trying to look at for the most popular products and the category they belong to. And this subquery is still embedded in my from clause. As you can see here, it's embedded in my from clause. So my subquery here, I'm going to count the number of products. That is the number of product ID. That's because my table, I don't have the order column. So the only way I can get the number of orders is by counting the number of product ID for each product. So that's the only way I can calculate the number of orders for each product name, because we are looking at the most popular products and the category they belong to. So now, I already created a temporary table here, which is my subquery, that's select count product ID, that's count product ID, which so I get number orders and then the product name and category from my sales data. So I'm grouping by product name and category. As one of our the rules guiding aggregation in SQL. Any column you don't aggregate, you have to group. You have to add it to your group by clause. So my product, that's why my product and my category is in my group by clause. So now if I run this inner query, see what to give me. So now my inner query now is giving me number of orders, product name, and category. That's the count for each product, the number of orders for each product, and the category they belong to. So let me run the whole query. And again, if you see my main query, you can see that most of the column I selected, they are from my subquery. That's number, orders, product name, and then the category. So let me run the whole query. So now this is the whole query now in descending order. So our products, the product with the highest number of orders is running shoes, and it belongs to the shoes category. And so, so let's move to the next query. So for this next query, our subquery is embedded in our where clause. Well, most of the time, when you see a subquery in a where clause, it's either you're trying to perform some aggregations. That is, when you are trying to filter your main query, let me put it that way. It's more or less like you're using your subquery to filter your main query, because now I'm trying to look for the products with unit price greater than the average price of all products. So the best way I can do this now is to embed my subquery in my where clause, because there is a condition attached to it. So now, if I run this my subquery, you see we'll get the average price per unit. So this is the average price. So now I'm trying to look for products that have products with unit price greater than this average price that we have here. And this is what we have, because my select is as product name column, so that's why we're having one column here. And if you notice something about this where clause, is that there is no there is no alias for this. So I didn't name the subquery, unlike others that I did, like this query, and I can see that I named the subquery. But for the where clause, there's a rule for that you don't name your where clause. Like when your subquery is embedded into your where clause, you don't name the query. Okay, now we have another one here, that is total price for each transaction ID. Because I have a column which is transaction ID, and I'm trying to see the total amount the total amount for each transaction ID, total amount spent for each transaction ID. And for this particular subquery, we have it embedded in our select clause. As you can see, our subquery is embedded in our select clause. We have select transaction ID, quantity, price per unit, and then our subquery is now calculating for our total price. So instead of me doing some aggregation in my select clause directly, so I use my subquery to perform the aggregation separately, still within the select clause. So if I run this, still within the select clause, so if I run this whole query, so as you can see now, we have our transaction ID, the quantity bought from each ID, and the price per unit, and the total price. You can see. The order of this query is in descending order, but in descending order in terms of the total price, not the quantity now. It's in terms of the total price. And so coming. Okay, so that's all for my subquery, and let's move to the next. So next one we have here is common table expression. Common table expression is just like is a one-time result set that only exists for the duration of the query. Like it's just like a temporary table that you generate when running a query, and it's just for that particular query you are running. Once you run the query, the table disappears. So that's what this common table expression is all about. And also CTE, also known as common table expression, it provides a way to query data that has hierarchy, and also it can also be used in place of subqueries or joins. It is temporary because its results cannot be stored anywhere, and it will be lost as soon as a query execution is completed, just like I said earlier. So for you to write a common expression, a common table expression query, the first thing you need to do is to specify the common table expression name. And mind the common table expression syntax starts with clause, and it can include one or more cities separated by commas. So first of all, you name your common table expression, as you can see here, with CTE name. Then the column, you create column with list of commas, as in you separate each column with commas, and then you alias it. Like, they are trying to tell us that with CTE name, column 1, column 2 as this. That is, they're trying to tell us that this column so you're trying to tell us that with CTE name as column 1 and column 2, and then we create something like a select statement as an alias. So after you define your with clause with the CTEs, you can then reference the CTEs as you would refer any other table, which is this second part of our syntax, that select column 1, column 2 from CTE name, where then you put your conditions. This is a single CTE syntax. We have the multiple CTE syntax where you have two CTEs in the same format too. Like you can see, these are multiple CTE syntax. We have with CTE name 1, then your column, and then you write your query. That's this select statement, and then you do the same thing for your second table, and then you reference the CTE. As you can see, select star from CTE name, then union all. You have to use the union statements for your multiple CTE here. Union all, select star from CTE name. I think, let me move to, okay, before I move to the examples I have on my some of the query sample that I have. There are some things we must know when when writing our CTE query. So for note that we cannot use the following clauses when writing CTE. You cannot use the into clause, you cannot use the option clause, you cannot use the order by clause unless you want to use the top function to filter your query. That's when so some of its use cases are, it is useful when we need to define a derived table multiple times within a single query. And it's also useful when we need to create an alternative to a view in the database. It is useful when we need to perform the same calculation multiple times on multiple query components simultaneously. It is useful when we need to use ranking functions like our row numbers and rank functions. Yeah, we have two types of common table expressions. We have the recursive and non-recursive. The first syntax here is, this first thing syntax is like a non-recursive CTE. And then the recursive CTE. Recursive CTE is a type of CTE that calls itself. That is, when you execute a recursive query, it repeatedly iterates over a subset of the data. That is, recursive CTE is more like a repetitive process. Like, it keeps referencing itself until all conditions are met, and then it stops. That's how recursive CTE operates. And as you can see, the syntax the syntax also starts with the with clause, just like the non-recursive CTE. Like with recursive, okay, now our syntax here now we have with recursive CTE, that's the list of column names, just like the way we did for our non-recursive CTE. And then we write our anchor query, that's like our non-recursive CTE. Now we wrote a query just like a select statement, then you union it with your recursive query. Your recursive query too is also like your normal select statement. And then where is like a condition you want your query to meet. So after that, then you now write your main query, which is select column form. You reference your recursive common table expression to run your main query. So let us see some of the okay, now for our common table expression, I think I have 3 queries. Okay, so our common table expression here now. So now I want to look for the total number of transactions. So now the first thing is I will name my CTE, my common table expression. So now I'm naming it transactions. So that's, and our CTE has to start with clause. So with transaction as, so now I'm trying to define what my transaction table is now. So with transaction as, select, that's count the transaction ID as total transaction from sales data. So this now is defining my transaction table. If I run this query now, so now this is the total transaction. That's the count of transaction ID we have on our sales data. So this is our transaction table now, like our temporary table, that's our CTE table. And then now I'm now writing my main query, which is select total transaction. Because I have just one column in my CTE table here, so definitely my main query is going to return a single column. So now let me run the whole. So as you can see from my main query now, say select total transaction, which was gotten from my transaction table. Now from transaction, that is my CTE table, like I'm referencing back to my CTE table. So now let me run the query and then we get the same thing. So let me see if, okay, now let's calculate the total transaction, total price for each product. Let me do that. Sorry. Thank you guys. Oh, sorry. Oh,
Don't worry, take your time. We're still here.
okay, so now can see now we can see the total amount for each product. Can see jeans is 137.5, but we don't have any order here. It's not okay. So now let me remove this product name here and put it in my select statement. Let me run the whole query. See, it's not going to run. It's going to show an error. Okay. The error is from this product name because product name is not, we didn't have this product name column in our transaction table here in this our city table. So that's why it's showing an error. So it's more or less like when we are creating our non-recursive CTE table, with the city is just like we're creating another table on our own. Like we're creating another table on our own. So you can perform aggregations on the CTE table and use it to create a different column. Like you creating a different column, a different table entirely on your own. And you can also join your CTE table on the table on your database too, using the join statement. So let me just take this product name back. So let me run now. Yeah. Sorry, I didn't put the product name here. So if I want the product name to select on our result table. So this is it. Then I can now put my order. I can put my order if I want to. Oh, sorry, I didn't put the. Oh, I ordered by product name. Let me order by without transaction. So this is it. Laptop is the highest, as you can see. So let's move to the next query. So for this query now, quantity sold for each product. Now this is our city table, like this is the name per city table, product name. As now I'm trying to create my table now, my product name table. So now I'm selecting some quantity as quantity sold, then the product name from sales data, then group by product name. So this is, let me run this city table. So this is our city table here, and this is our main query. So now our main query now is we are trying to select the product name, the quantity sold from our city table. We still get the same thing though. The difference between when you use your city table and when you just do like run your normal query is just the how like it is the performance. Like the time is different. Okay, now let me, when I run this query now, this query ran within 226 seconds. Abi? Okay, 160. And now let me run the whole query. I'm doing this again first. So as you can see, this is city table. Like it's kind of, oh, I didn't run the whole table, the whole query. So as you can see, when you write normal query, it takes time for the server to run the query than when you use CTE to write your query. When you use CTE to write your query, it's more or less like you optimizing your query because your query runs faster. Now let me, okay, now I think I have one I did somewhere. Okay, now this query and this query is the same thing. It's my city table that I created. You see the seconds it will take to run the table now. You can see 188 seconds. Now let me run the whole table using city. Can you see? 89 seconds. Like that's 100 seconds difference. So when you are working with like a larger data set, it's better for you to use um, it's better for you to use a common table expression to write your query because it will make your query lag and the response time will be faster. Okay, now I have another one here. So now this one is the top 6 performing cities by sales. So now the name of my city table is cities, and I've created my table here. That's the store location, the total sales from my sales data, then group by store location and Let me run the inner one. Oh, sorry. Can see 96 seconds. So let me run the whole query. Can you see 77 seconds? So if you want to optimize your code, it's better for you to write your query using common table expression, because it doesn't, like, okay, the table you are creating is not stored on your database, so it's not occupying space on your disk, on your database. So it runs faster because it's a virtual table that you are creating. Okay, now for this one, on top five performing cities by sales. So this is it. Then I select this is my main query here. Select store location, the total sales, and total sales divided by, I performed my my aggregation in my main query. That's for the percentage in my main query. I didn't do it in my CTE table. So I did it in my main query here. So that's why we have some total sales over star 100 times. So okay, now for our last query for the common table expression, we have total quantity for each category. That is, we want to know the total quantity of products sold for each category. So my first, this is 2city. Now I told you we have the single city and the multiple one. So this one is a multiple CTE because we have 2 CTE table here. So this is my first CTE table. I already defined it here. That I select category, some quantity as total quantity. Then my second CTE table is like the continuation of my first CTE table. So now my second CTE table is just performing an average aggregation. That's average of total quantity. That's what my second CTE table is performing. And then my main query. So my main query is going to reference my my second CTE table. Though we have different ways of writing it, you can use your join clause to join the 2 CTE table depending on what you are trying to achieve. So now let me run the whole query. Okay, let me run the first query. So this is the first query. So let me run it together with the second query. Oh, mistake. Sorry, I'm supposed to pick up my week. So this is the result of the whole query. So now I want to try to do something to see the difference between separate, that's difference between using two city table and using one city table. So I'm going to bring this my second city table to my first city table, the calculation, and let's see what we're going to get. Okay. Oh, sorry, I'm not supposed to. Let me set the calculation. Mm, mm. The method I want to use is not going to work out. So let's just stick to this. So that's all for my common table expression. And let's see what happens. Okay, so there are disadvantages to using common table expressions. So city members are unable to use the keyword clauses like distinct, city members are unable to use the keyword clauses like distinct by having top and joins. So they can only be referenced once by the recursive member, and we cannot use the table variables and cities as parameters in stored procedures. So a city cannot be nested, and it cannot be reused in another query. Like I said, it is a temporary table, and once you run the query, it disappears. So the number of columns in the city argument and the number of columns in the query must be the same. Just like what I explained earlier, I said the columns that are created for my city table, and when I'm writing my main query, I have to reference those columns in my city table when writing my main query. So let's move to query optimization. So query optimization is the process of defining the most efficient and optimal way and techniques that can be used to improve query performance based on rational use of system resources and performance metrics. So the role of a query optimization is to find an execution plan that reduces the time required to process a query. And also, the purpose of query tuning is to find a way to decrease the response time of the query, and also to prevent excessive consumption of resources and identify poor query performance. So we have tips on how you can optimize your query. Running query during off-peak hours. That is, when you run your query during peak hours, depending on the policy guiding your company database, probably is during the peak hours you run your query, it will overload the server, and that will lead to it will overload the server, and that will lead to slow performance. That is, the server will run slowly when you run your query during peak hours. And also avoid using select all, that is select star, when writing your query, because when you use select all, if you have a large data set in your database, then means the query have to go through, probably you have millions of data in your millions of rows in your data set. That means the query have to run through those columns, that's to run through those rows one by one before returning. So it's better for you to just select the field you want, the column you want to query, instead of using your select star, because it will reduce the performance of your query. And also avoid using select distinct. When you use select distinct, so let's assume you have millions of rows in your data. So that means your server has to go through the large volumes of data, and as a result, it will make your query run slowly. So it is advisable for you to avoid select distinct and also use the select field instead. It's just like you using the select all and select distinct, because select distinct is just like you selecting the unique numbers. So it has to go through those rows one by one to select the distinct number. So it's better for you to just use the select field instead of using select distinct if you want a good query performance. And also avoid too many joins when writing your query. See, when you had multiple tables, that is when you had multiple tables to a query and you join them, it ends up overloading your server, and a large number of tables to retrieve data from may result like when you use too many joins for your query, like it's just like you bringing in so many tables, and so instead of using too many joins, it's better for you to just split your data in a single query. That is, you separate it, you split it into several separate queries, which can later be joined. So when you split your queries, instead of joining, you avoid using unnecessary join statements when writing your query, and also use wildcards at the end of a phrase only. So wildcards is just like a placeholder for words and phrases. So to make your data retrieval faster and more efficient, you can use this wildcard in your select statements at the end of a phrase. Okay, just like you are looking for names that start with probably start with A or ends with A. So instead of just selecting the whole column, you just use a wildcard to do that. So, and next one is avoid using multiple or statements in your filter predicates. So that is when you need to combine two or more conditions. For this particular one, that is avoid using multiple or in your filter predicates. It is recommended for you to remove or operator when writing your query, and instead of using or, you split your query into parts, separating, like you split your query into parts.
Hey, Dolapo? No,
Yeah.
that's it.
Thank you.
Okay, so I was just saying that we are going a little bit over the time, but I think I said it at the right time. So thanks a lot for that presentation. That was actually great. I'm gonna go into the chat now and see if there was any questions. So we have a question from, I believe it's Sefas Shokwu Wiki. Definitely said it wrong. So question, please, in the example that explains the most popular product, I'm trying to clearly understand the logic. Won't transaction details be important? By Sefas.
Sorry, I didn't get that question.
Okay, Mr. Sefas says, please, in the example that explains the most popular product, I'm trying to clearly understand the logic. Won't transaction details be important?
Okay. Yeah, for the most popular product and the category they belong to.
Okay.
Yeah, I used this thing. Okay, now select number of orders, the product name, category from product ID. I used product ID here because my transaction ID here is not, is, let me say, is in serial, or is more or less like a serial number. And the reason why I use product ID is because I'm trying to count the popularity of the product based on the number of times they ordered, not in terms of sales generated. I don't know if I answered the question correctly.
I think it's
This
fine.
particular query is based on the number of times a product is being ordered. That's what this popular product is based on, not in terms of sales. So if let's assume I'm assuming I want to do that for the popular products based on sales, then I can bring in the price and quantity and discount that's to calculate the total sales. But this is just based on the number of orders for each product. Okay, let me run the query. You can see it's based on the number of orders. So our popular product here is running shoes because it has been ordered 6 times and it's under the category shoes.
All right.
Is there any other question?
Yeah. So there's another question by Mr. Ibrahim. So how can I retrieve data from the server using PostgreSQL? Because I've watched a lot of videos, but my SQL was used. Kindly explain. Thank you for the job. I've learned a lot, especially CTEs.
Please, can you repeat the question?
Oh, sorry, no problem. So Ibrahim says, how can I retrieve data from the server using PostgreSQL? Because I've watched a lot of videos, but my SQL was used. Kindly explain. Thank you for the job. I've learned a lot.
Okay, how to retrieve data from the SQL database?
Yeah, from PostgreSQL, because he couldn't find out how to use it from MySQL.
Okay, this is okay. I don't know if you are talking about the select statement that is retrieving all the data to see what you have there. I don't know, maybe that's what. Okay, let me use as a from sales table. So now this is me getting all the data from my table. Oh, sorry, wrong name. Did that answer the question? Because I don't understand what it means by retrieving data. Like, is it after you import your data and you want to have access to your data, or I don't know, maybe you should try to explain.
Well, like maybe we're still waiting, but as we're waiting for him to try to explain, we can move on to the next question. So from Mr.
Okay.
Olesegun, hi Dolapo and the team. Thanks for this great presentation. Please, is it possible to have the data set used in the presentation for us to practice? So we'll supply the data set right now. We'll supply at the end of this webinar. And now okay, Ibrahim posted again. He says, I mean how to obtain data from a company server rather than create a table. I think that's what Ibrahim said. And to add some more information to the last question, he's asking how to obtain data from a company server rather than creating a table.
Okay, there are different ways depending on the database system your company is using. It depends on the database system your company is using. You can, okay, now I created this table myself, and you can also use copy function to import your data into your database system. So I don't know which of the database system, but I don't know the server your company is using, the database system your company is using. But if your company is using, how will I put it? Let's just assume they save their data in Excel spreadsheet. You have to change your file to CSV for you to be able to import it into Postgres. So after saving your data into CSV, you have to then you create a table. You create, okay, let me just close this so that I can explain. Okay, now this is the server. This my server Postgres 15, and this is my database. So I have two databases there, that's mine and Postgres. So let's assume I want to import a file into my database now. First thing I need to do is to come to my schema here. So once, okay, let me just close this. So this is my database. I open it. So I come to my schema. The schema is open already. So I open it now. Under public, you will see table here, and then you click on it to create a new table. You name your table. Let me name it dummy. You name your table, then come here to create column. That's the column in your data set that you're trying to import. So you have to like use this to create your column, and the name must correspond with what is in your data set. The number of columns you create here must be equal to the number of columns in your data set that you're trying to bring into your database. So let's assume you have 3 columns in your data set. So you have to create 3 columns in your database, and then the data types too. You must make sure that the data type you are choosing is correct for each of the column. If not, Postgres is going to throw an error for you when you are trying to import. So you have to make sure that your data type too is also correct, and then you signify any of your column that is primary key. So if any of your column has a primary key, then you on your primary key here, and then you save. Let me just create something random here. So now I know that my amount is going to be my location is going to be, okay, let me just the number of rows integer. So let's just assume number of rows is my primary key. So now primary key is on, then I save. Now can you see that we have 2 tables there? We have 2 tables there now. So this was the table I created. So this was the table I created, and these are the columns. So after doing this, then you click on your table, that's the table you created, and then you click on import or export data. And then you go to this file name, that's the location of your file. That's if your data set is in a spreadsheet. So then you go to the location of your file, you click on anyone, but I can't use anyone here because I didn't create the exact column my table. So then you choose the format. After that, you come to options, you check out the delimiter because it's a CSV file, so I'm choosing comma. Then so if your data has header, then you have to turn on the header. And then for columns, so it automatically pick the columns in your table that you created. So these are the 3 columns I created. So already, and then you can click OK, but it's going to show error because it's not the same thing with, like, the columns I created is not the same with what is in my data set. I don't know if I've answered your question.
Hello, Chidi, can you ask the last
Any
two
other
questions so we can close?
All right, so just 2 more questions before we finish off. So I just wanted to ask very quickly, how did you guys start? How did you guys started as a data analyst? That's the first question, anyways. How did you guys start as a data analyst? The early parts of your career.
Okay. Well, I started my data career after my first degree because I studied anatomy in school. So after finishing my first degree, I was thinking of what to do because obviously my course is not really relevant in the society, like in Nigeria. So I was thinking of what to do. So someone introduced me to tech, and I did my research. And that was when I discovered about data analysis. I did my research on data analysis to see if it's something I would love to do. Because let me say right from high school, I love anything that has to do with numbers, anything that has to do with calculations. And also, I think that was what actually fascinated me to go for data analysis because I had like 4 options. I was thinking of either going into product management or project management or front end um, development, but I settled for data analysis. And at first, I was like, let me just test the waters to see how it's going to look like because I was kind of scared. Like, I don't have, let me say, when I was in school, I don't like anything that has to do with computer. Like, I hate computer with so much passion. I don't know why. But all of a sudden, I just developed interest in using computer, and I was like, okay, let me just do my first course. So I did my first this thing with entry level data analysis with entry level, and it's also interesting, like the fact that data analysis is all about you trying to know the cause of something and providing solutions. Like you can the data. You don't need anyone to tell you. If you analyze your data very well, you see some like trends and patterns. Like it's also intriguing, and I was like, wow, I would love to know more about this course. And after doing my entry level data analysis, I joined a community that's Chicode Africa, and let me say the community really helped me because I was able to meet with other data professionals, and we had series of trainings which really helped me to skill up too. And after that, I registered for the Google Data Analytics, and I think that was what even gave me more eye opener into data analysis again. And I did the Google data analysis because the most important skills you must have as a data analyst is you must know your Excel very well. You must know your Excel very well. You must know one database language, SQL. You must know it very well. And you must also know either Power BI or Tableau for your visualization. So, like, those are the three important things you must know as a data analyst. So after doing my Google Data Analytics course, I also took some other courses that are not, let me say, that are not really relevant to data, but I was able to get the soft skills that I need to become a good data analyst. Well, my first job wasn't in data. It was more or less like finance.